Oracle is divided into two parts. The Oracle is divided into the logical structure. The Oracle is divided into the physical structure. So today we're going to see the logical structure. So how the logical structure of Oracle works, and what are the different components are there inside the Oracle logical structure. So this is how my Oracle logical structure looks like. Okay. Now I have a database. Let's say it is a prod database or any database you name it. Now this database is comprised of a couple of tablespace. Okay. Now here I have three tablespace: system tablespace, then I have user tablespace 1 and 2. Now these two tablespace are again divided into segments. Okay. Now each object inside an Oracle database is called a segment. So a table, let's say you have created a table, so that table will be represented as a segment. If you create an index, so that index will be represented as a segment. Okay. So when we query the different views and all, that way we can figure it out. Okay, this segment is an index type, this segment is a table type. Now again the segment is divided into, you can see this particular segment, I have taken one segment. This particular segment is divided into extents. Okay. The extent concepts are same, whatever concept you are having in SQL Server as well, where in SQL Server the extent is a combination continuous 8 pages. Okay, where in here the extent is a continuous 8 blocks, 8 database blocks. Okay, and each extent is a combination of blocks. Okay, so this is what it's it's not a 8 continuous 8 blocks, it is a continuous blocks only. It can be 2 blocks, it can be 3 blocks, but it has to be a continuous blocks. Okay, whereas in SQL Server it is a continuous 8 blocks. So each extent size is 64 KB. Okay, but this is not the case here. It is just a continuous data blocks. It can be 2 blocks in an extent, or it can be 3 blocks, or it can be 8 blocks in an extent. Okay. Okay, so this is how the extents. So database blocks are allocated to extents as specified in the data storage clause. So each object, whether it is a table, index, or a cluster, is allocated a single segment, which I have told you, which is comprised of one or more major extents. Okay, so segments are stored to the table space determined by the DBA when the object is created. All of the table spaces taken together comprises your databases. Okay, now this is my databases. Now this is my two table space. Okay, this database comprised of two table space. One is a table space, another is a index table space. Now you can look in the tables. So two tables I'm having a department table and I'm having an employee table. Now the department table size is, it comprises of two extent. Okay, the extent size is 16 KB, which means each block is around 4 KB. Okay, so 4 into 4 is 16, so 16 KB is the size, and another extent is having only 2 blocks. Okay, now the block size should remain the same. Okay, individual blocks cannot be different. Okay, until unless if you have not configured any other inside the database buffer cache the different components like 2K, 4K, or 16K. Here I'm considering the block size as 4K only. So it is 8K, so 2 block size is there. Okay, so this is the, now what would be the size of my department table? It will be 16 plus 8. Okay, it will be 24. Okay, now coming to the employee table. Now this particular employee table segment is having only one extent of size 16 KB. So the size of this particular is 16 KB. Okay, the table is 16 KB. Coming to the index table. So the index segment has only 3 data blocks. Okay, each is having the size of 4, and the extent size is, hence the extent size is 12 KB. Okay, so I can tell that the index size is 12 KB. Okay, got it? Any doubt till here? Okay, fine. So this is also one of the example which I have showed you here. One of the extent is, it can be any segment. Okay, whatever. Its total size is 96 kilobytes. Okay, and it is divided into 2 extents. Now this extent's size is 24. Okay, all are 2 KB in size, the data blocks, and this extent size is 72 KB. All are 2 KB. But always remember one thing in mind: these are all continuous data blocks. Okay, there is no free space in between them. If there is a free space between them, then that cannot be an extent. Okay, the extent comprises of continuous data blocks. It can be 1 also, it can be 100 also. Okay. So this is what I have written here. A table space, an Oracle tables database must always consist of at least 2 table space. So at least 2 tablespace you require for your Oracle database, though we have more than 2 tablespace. Okay, especially if you are using it for your application. System and sysocs are the most critical ones. Okay, you can have multiple tablespace as well, but these two are the common ones that you will find. One more tablespace is there is undo, but you can start your database without undo. Okay, but you cannot start your database without system and sysocs. So what exactly is a tablespace? It's nothing is a logical storage facility, or you can call it as a logical container for storing your objects such as your table, indexes, procedure, packages, sequences, clusters, or any other triggers or any other objects for your database. Each tablespace has at least one physical data file that actually stores the content of your tablespace. So always remember, whenever we are creating a tablespace, we have to assign at least one physical data file, without which, because if there is no relation between logical and physical structure, the logical structure cannot exist. Okay, so the physical data file establishes the connection between the logical and the physical structure of your Oracle database. A tablespace can only belong to only one database. Okay, you cannot have a cluster tablespace. Okay, we don't have a concept of cluster tablespace where a tablespace will be belonging to multiple database. No, in Oracle, a tablespace will be belonging only to one database. Tablespace, you can bring it online and you can take it offline for your purpose of backup and recovery, except for the system tablespace. Okay, so always remember, both system and sysoc should always be online. They can never be taken offline. Okay, if any corruption happens, then you have to go into your mount stage and then you have to do the recovery. Okay, and that has to be, depending upon whatever log files, if you doing point in time recovery. Tablespace also, you can make it either read only or read write. Okay, so if a read only tablespace is there, then there will be no archive logs generated for that, obviously, because it is a read only, no write is operation is happening. But if it's a write, you can also make it as read write. But most of the tablespace you will find in the actual environment as read write only, but you have the option to make it read only. Now coming to the data files, tablespace are stored in data files which are physical disk files. Okay, a data file can only store objects for a single tablespace. Okay, but a tablespace may have more than one data file. See, a tablespace can have multiple data files. Okay, it can have around 100 data files as well. Okay, and the size is a limit factor here, because of depending on the OS, what type of OS you are using, whether it is, because in the Linux version, I don't think so you can have more than 32 GB of single data file. But a data file, a single data file uh, cannot be configured for two different tablespace. Okay, so it will always be belonging to one tablespace. The DB can change the size of a data file to make it smaller or later. Okay, so this is how we increase the size of a tablespace. If you want to increase the size of a tablespace, so basically nothing, you have to basically resize your data file. Okay, you can make it smaller also, you can make it bigger also. Okay, also if you don't want to do it manually, you can do it auto extend. So auto extend will work till you have your space in your disk. Okay, so this is auto extend will basically make it size dynamically. Okay, it will grow dynamically. Coming to the segments, segments are nothing but a logical storage objects that are created within a table space. Okay, so for example, just previously I showed you a department table and an employee table. So both are nothing but segments. So segments can be index, segments can be table as well. Obviously, a typical segment table space has many segments. Yes, a single segment cannot span table space, but can span data files that belong to a single space table space. So what does it mean? A single segment cannot be configured for, or cannot be stored inside multiple table spaces. Okay, so a single let's say our employee table is there. Okay, and it belongs to an employee table space. So an employee table cannot belong to department table space. No, it's not possible. An employee table will only be belonging to an employee table space, only one table space. But yes, an employee table can be span multiple data files belonging to that particular table space. Coming to an object, extent. Each object has one segment, which is a physical collection of extents. Extents are simply collection of your continuous disk storage blocks. Okay, so extent, a table or an index go additional extents are added to your segments. Okay, a DB can add the extent to the segment in order to tune performance of the systems. So as a DB also we can keep on adding the extent, but usually we don't do it, because if there are so many table spaces or so many segments are there, it becomes difficult to keep track how many to add. So from 10G onwards, the extent management has been made auto. Also, a point to remember that an extent cannot span a data file. Okay, so an extent can only belong to one data file. It cannot spanning to multiple data files, or it cannot be allocated for different for multiple data single extent. Now the smallest unit of storage is a block. The Oracle server manages data at the smallest unit in what it is termed a block or a data block. Data are actually stored in this block. So always remember, in Oracle the data are actually stored in your blocks. Okay, so blocks are stored inside your extents are stored inside your segment are stored inside your tablespace. So this is the logical structure of your Oracle database. So this is how the anatomy of a database blocks looks like. Okay, so the data grows from the down. Okay, the data loads from the bottom. Okay, so this is the row data, this is the free data, this is the row directory, this is the table directory, and this is the header. Okay, so the block size varies. Okay, so whatever the block size you give, it is defined by this particular parameter. By default, Oracle, if you don't define this, Oracle will take your default block size as 8 KB. Always remember. Okay, so in some of the database, you will not see this particular parameter defined in your P file or SP file. Okay, so let me have a look what is defined in my database. So there is a parameter, no show parameter db underscore block. Now you can see here block size is 8 KB. Okay, so it is 8 KB. Why it is 8 KB? Even in SQL Server, most of the database you will find 8 KB, because the operating system block size itself is 8 KB. Okay, so whatever is the operating system block size, that is the block size is taken by the database only. Okay, and that is what is recommended. So whatever the block size is used by the OS, so that or the server, that block size you need to give it to your database or the application. It is defined, if even though if you don't define, by default it will take us 8 KB only. Now what else do you mean by header? What exactly the header contains? See, the header contains your generic information. Okay, like what type of a segment it is, what type of a segment or a block it is, whether it is the block belongs to a table or whether the block belongs to an index. Okay, so what type of a block it is a index block or a data block. It is defined inside the header along with the header the block address. Okay, table directory basically contains the information about table having rows in that. Okay, so tables information it contains. Now the row directory contains information about actual rows contained in that block, how many rows are there, okay, in that particular block, so will be stored inside your row directory. Free space, certain amount of free space you need to leave in your database block. By default we have a parameter known as pct underscore free, percentage free, and by default it is 10%. Okay, even though if you don't define any parameters, so by default Oracle will leave 10% of your database block for future updates. Okay, for future updates or future inserts and all. Row data as the name specifies is actually contains the row. Okay, so whatever contains table or index data. Okay, so this is how the anatomy look like, and always remember, whenever any data loads, it loads from inside the row directory. Okay, so make sure your free space is at least 10%. Anyways, default is 10% and this is 40%. Okay, so 40% will be used. Even though if you don't specify, we have two parameters in Oracle. We have pct underscore used and pct underscore free. So pct underscore free default value is 10%, which means that minimum 10% will be left free for future updates, especially for future updates, not for insert, for future updates. Okay, and percentage used means by default the setting is for 40%. So 40% of your database blocks will be used for the row data. Okay,